Hey guys, and welcome back to another video. And today we are going to be making a compound known as potassium hydroxide. Now in a previous video we made potassium carbonate, and this is my impure one of them, which means it's not totally pure. I used a pure source of it to make potassium hydroxide using calcium hydroxide, but I'm going to be doing a different method today. So we have 11 grams here, and this is going to be decomposing potassium carbonate at high temperatures down to potassium oxide and carbon dioxide. Now this can only be done in something as hot as something like an arc furnace, which I made myself, and a blowtorch or something will not work. It will not get hot enough to decompose it. It has to be over 1,600 degrees Celsius, so very hot, as potassium carbonate is very difficult to decompose. Upon decomposition of our potassium carbonate, potassium oxide can be reacted with water, and this will then go ahead and form potassium hydroxide. The hydroxide is what we're going to be using. And this potassium carbonate was originally made from cream of tartar, which is potassium bitartrate. So this is making potassium hydroxide from household materials that you can easily obtain. And potassium hydroxide is honestly not the easiest thing to get, but it's very useful for neutralizing acids and forming potassium salts, and it has a variety of other uses. So the first thing that we're going to have to do is take this 11-gram sample and bring it outside and put it on my brick, and then arc furnace it to very high temperatures, and we'll see what sort of reaction we get. So I'll meet you back when we're outside with my arc furnace. Okay, so it's sort of difficult to see, but over there you can see we have our pile of powdered potassium carbonate. Now I only added half of it because it was a fairly large amount, and I don't want to not convert all of the potassium carbonate. I want to convert as much as possible, so I'm going to be doing it in 2 batches. And I just have a beaker of water, because afterwards we're going to add it to the water. It should heat up a lot as potassium hydroxide is formed. So this reaction is going to be releasing carbon dioxide and forming potassium oxide. The potassium oxide must be worked with very rapidly, as it will rapidly react with both carbon dioxide and water in the air, and can easily convert to other compounds which we do not want. So I will now go ahead, set up my arc furnace, and start electrifying this at very high temperatures until it, I guess, all converts to potassium oxide. There's not going to be a real huge indicator that's happening, and I've never tried this before, so this will be interesting. So, yeah, I'll go do it. Okay, here we go. Okay, I think that should have done it. Okay, so now we must scrape it off. So I will grab thing. Hopefully this works. Looks like it worked. I could under my welding mask I could see bubbles appearing. So I'm really hoping that this did work. Probably end up cutting a bunch of this footage. Okay, so I only actually did end up heating up half of that because my arc furnace caught on fire. I have 3 transformers in it, and the smallest one always gets super hot. And I had just been using it before this video, and so it overheated because I wasn't paying too much attention, and that one transformer caught fire. But that's not a problem because the other 2 were totally cool because they are much larger, so I will just rewire a 3rd transformer and replace it later. But I cannot finish up with the rest of it right now. But that's fine because this is clearly enough for what we need, which is demonstration purposes. So you can see there's lots of impurities floating in here. So what we can simply do is take this and filter them off. So that's the first step. So I'll go ahead, get some filter paper, and filter it. Okay, so I filtered it into here, then washed this out and transferred a little bit over to here. We can test to see if we actually have potassium hydroxide present or not by the addition of some aluminum foil. Just a very small amount, not a huge amount by any means, but the aluminum foil will be useful because the aluminum foil will indicate that the potassium hydroxide is present because it will dissolve aluminum. However, the potassium carbonate will not dissolve aluminum. So, we will simply insert this in here and wait a moment and see if any bubbling occurs. So I'll meet you back if I see any. Also, we could take some litmus paper here, as you can clearly see, and I did test it a moment ago, but just to prove that this is indeed basic, we can dip it in again. And you can see it turns blue. Now, of course, this isn't the best indicator, as potassium carbonate is also very basic and will turn litmus paper blue, but our aluminum test should definitely prove whether or not we actually have it. So I'll let this sit for a moment and see if any bubbles occur. Okay, so I'm rather excited now. I don't know if you could see. Oh, it's really difficult to see. Right along there you can see that line across there. This is a bit lighter over here than, oh, I don't want the reflectiveness, than on this side. So this is the part that was in the solution, and it's been slowly dissolving, which means we have potassium hydroxide, which is rather dilute. And I will show you how to purify it in a moment. But so that's on that side, and then over here we have the aluminum foil that was untouched, and the same thing appears on the other side. So this very clearly worked at dissolving this aluminum foil, which means we definitely made some potassium hydroxide, or else this would not be possible. So this shouldn't be too impure, and we are going to purify it, so I'll just add it back to our other beaker, and actually I'll put it in the smaller beaker. Whoops, sorry. Put it in the smaller beaker, and we're just going to go ahead and boil this down. And upon boiling it down, we'll be left with a solid mass. And then I'll show you how to purify this, because there's still copious amounts of potassium carbonate in this solution, because not all the potassium carbonate would have actually turned into potassium oxide. And I'll show you how to get rid of that in a moment. Okay, so this is quickly for both methods to produce potassium hydroxide I've showed. You can see we have the potassium hydroxide from each method. And I'm just doing it at the same time because I want to save ethanol. So in a previous video we actually distilled some nice 95% pure ethanol, and we're going to be using this because potassium hydroxide is quite soluble in ethanol. However, potassium carbonate is essentially insoluble in ethanol, so that leaves us an excellent method to separate them, because our potassium carbonate can simply be filtered off, and our potassium hydroxide will be in solution and can be boiled down to obtain the pure potassium hydroxide. So weigh out some ethanol, or measure out some ethanol, and place in both of these potassium hydroxide samples. Okay, so as you can see, we now have a solution that's relatively clear with a bit of gray gunk filth at the bottom. That's most likely impurities and potassium carbonate, as it's not soluble in ethanol. But most of it did dissolve, and that's all the potassium hydroxide, which is now dissolved in this ethanol. It is important to use high purity 95 or 100% ethanol, just because potassium carbonate is very soluble in water. And if there is too much water present, we're going to get a lot of potassium carbonate contamination. So we can now quickly filter this off with a coffee filter or something, and then boil off all the ethanol to obtain a nice pure potassium carbonate salt. So do that and meet you right back. Okay, so you can see that now that after we boiled that down, we are left with some beautifully nice pure potassium hydroxide. And this is quite pure because we have no potassium carbonate contamination. And yeah, that's basically how to make potassium hydroxide from household materials. And it's not exactly efficient. Probably have about 2 grams or 3 grams here, but it's enough to do some reactions if you just need a bit of potassium hydroxide. I highly recommend going ahead and buying it online or something. You can buy several pounds of it for $20. I mean, it's not super expensive by any means, but I guess it's fun to make it on your own, and if you'd like to try the experiment, then you could try either method, because this, of course, at the end of both videos is going to be exactly the same. They just originated from different points. Anyhow, so I hope you guys enjoyed, and see you in the future video. Bye.